Well, hello, I'm 𝗣𝗶𝗱 𝗔𝗳𝐵𝐿. Welcome back. In this video, I'm going to cover how I built a fairly ultralight grapple. A lot of the store-bought manufactured grapples for these things are almost scaled up for the next size up machine. They're very heavy and they weigh down your capacity so you can't lift as much with the grapple. So I built this ultralight grapple for around $200, salvaged a cylinder, salvaged a lot of the metal, and just built this in my shop in my free time. So if you're interested in how I built this thing and maybe get some ideas on building something like this for your own, stick around, check out the video. So after looking over a bunch of different store-bought arches online, seeing what was available, I made a basic sketch of what I kind of wanted, dug through my metal, and here's some 2x3 scrap steel. Here's some other scrap steel that's 2x2. This is going to all make up the backing plate, the main grapple body. And cutting all this stuff with my Evolution saw. If you're interested in one of these chop saws, they work really well. There'll be links below to a promo code. They'll save you a little bit if you end up using that, and it helps me out as well. Here's some steel I did not have kicking around. My buddy gave me it. It was thick wall, 1.5 by 1.5. It's going to be for the lower forks, and that's I think 3/16 inch. Pretty sturdy stuff, maybe a quarter. Anyhow, just drawing out some stuff on the side here, drew up some basic stuff from my arc droid, and these are 3/16 side plates for it. Just kind of makes it a uniform structure right here, and this arc droid sure makes quick work of cutting out bits and pieces and duplicating parts, which is really nice. So it's wet in the Northwest, it's late winter, and it's kind of hard to get motivated on projects in the summer around here, but good time to be working in the shop when it's pouring down rain. Here I'm just cleaning off all the mill scale on these cut parts and everything before I weld it. So rust, mill scale, anything like that. If you clean it all up before you weld it, you're going to have a much stronger weld. It's a little tip there if you're getting into fabrication. A lot of this stuff right here I'm cleaning up. It's all old salvage with paint on it. Again, get rid of all that paint and rust and mill scale, and you're not going to regret it. If it's worth welding, it's worth cleaning first. Here I'm using my Machpro. I'm not sponsored by Harbor Freight on this welder. I paid out of my own pocket for it. I've had it for many years now. It's the Machpro 220, and it's a pretty nifty welder. I mean, for under $1,000, I think you can get them for on sale. They work pretty well. Pretty robust welders. Never have to worry about duty cycles on any of this project. Here you can weld as much as you want. I've never hit a duty cycle on that or my titanium. They're pretty solid welders for the money. So here I'm using my Langmuir Systems fitment table. I adapted to a hydraulic Harbor Freight roll around table. It's kind of nice, adjustable heights. Beauty of the fitment table is you can drop your clamps in any of those holes, or you can drop in bolts or pins or anything and align stuff, make everything really nice and square. This one's kind of expensive. I wouldn't recommend it unless you're doing a lot of fabrication, but I think even Harbor Freight and on Amazon you get a cheaper version of these fitment tables. They're probably only a third of the thickness, not nearly as thick, but you know what, if you are getting into welding or have been dabbling with it and you don't have a good welding table, just treat yourself. Go to Harbor Freight, buy 1 or 2 of the small fitment tables or order them on Amazon. Some of them actually even come with simple clamps. You can make your other DIY clamps. It's going to make jobs like this a hell of a lot easier to get everything aligned, because when you start welding the stuff, heat starts warping things and bending things around. So clamping is key, and aligning everything is pretty important. So treat yourself if you've gotten into welding, and just get yourself a nice little welding table. So here we're using the arc droid to cut out some more hinge brackets. These are going to be what are going to support the grapple arms. Unfortunately, in making this video with all the welding sparks and the plasma cutting sparks, it destroyed the lens of my GoPro camera. So that's another $25 lens I got to buy. I've ruined countless lenses and things like that from welding around them over the years of my channel. So if you found this video helpful, inspiring, you know what I've always make of these videos to try to bring you along, encourage others, give you tips along the way. Maybe consider buying me a coffee. That'll help it buy a new lens for my GoPro at least, so I'd appreciate that. Right here I'm using 1.5" by 3" salvage steel for the grapple arms. And I'm cutting these at 15-degree angles butted to each other, which will make a 30-degree bend. And at the very end, I'm cutting them at 45 here. I'm going to go through and cap it. So here I'm cutting off some tubing that I had kicking around here. I found if you go through with a die grinder and grind out the center weld, it fits a 5/8 of an inch bolt really well. That's what I'm going to use for the pins. Drilling some pilot holes here. I don't have a drill bit big enough to bore out for that tubing, so I'm going to drill through all the way through the tubing here with the small pilot bit. Lining up the arc droid, I got it calibrated to cut a hole big enough where I can drop that tubing through. The idea with that tubing is you drop that through, weld it in place, and it gives a much more robust section for your bolt to go up against. Longer wear, it should hold up a lot longer. And you know, I didn't have a drill bit big enough, so might as well implement the tools I got, and that's the arc droid. Again, we're going through here, cleaning off all the rust and paint, cutting off some old welded on sections of tubing. Like I said, it's salvage, so there was something else welded on here I'm removing. I don't mind using salvage, but man, it takes a lot longer to clean things up. Here again, I mentioned earlier about this fitment table. Here I'm dropping these bolts in for alignment, kind of using it as a simple guide so I can weld this one up and make sure the other fitment arm has the same curves and everything. It's a pretty good jig table just to set up really simple jigs for, making basically these look like little mini lawn tractor loader arms right here, but these are the grapple arms. So here I'm finishing up die grinding out some of the inner weld of those tubes I cut earlier to make sure it fits a 5/8 inch bolt. And I'm just kind of tack welding these things in here, getting them aligned. I'm going to go through and weld the ends and just grind them down after I'm done. Grind down the high points. There they are, kind of finished up. Dropping a 5/8 inch bolt. That's going to be the pin. Really simple. Like, I mean, if you were building a lawn tractor little loader arms, basically almost the same thing. Here I got these parts, they clearance everything really well. These are those brackets I cut earlier for the hinges, but I don't like how close everything comes. There's maybe 3/8 of an inch. So I'm going to go through here, cut some 45s on here, and end up capping these things in just to kind of finish it off and keep the water out of the arms and make it just look a little bit better. Because these little caps on top are just kind of cosmetic to kind of clean things up and keep water from getting inside the tubes, I'm just going through and grinding off some of the welds and rounding it off and making them look a little nicer. There's a saying with carpentry, measure twice, cut once. It follows suit with metal fabrication. Here I was measuring, figuring out where the center of the grapple is and figuring out where I want to put my hinges. Measure twice, cut once, put tacks in really simple locations where in case you want to change something, you can grind the tacks off easy. It's a lot easier to grind a tack off than it is to cut a fully welded part off. You can always get around to finishing off the welds later. So I dug around up in my shop loft and I found this cylinder. I forgot a friend of mine that does a forklift repair gave it to me quite a few years ago. Same 5/8 pins, basically, same as this. And it's 8-inch stroke, which I thought I would kind of need for something like this. So I just cut out some mock-up parts pieces here this is really thin metal, 1/8 inch or less, just so I can mount it on here and just kind of figure out the stroke and the opening of this. And once I figure that out, I'm happy with it. I'll cut these off, they'll just be tacked on, and cut out some thicker stuff and trial and error, figure out the stroke on this thing. And top cylinder mount test strike one. Cut a new one out, designed it different. This one allows the cylinder to drop at a different angle. Now I'm working on the lower cylinder mount. I'm starting off with some round tubing and going to cut a bracket here that can be rotated on the pipe. This allows and gives me a more adjustment to figure out the stroke and make sure it works properly, because you can rotate it clockwise or counterclockwise to get the cylinder mount just right. Because I mean, I would have been fine to open to that point, but heck, I'll take that. There we go. So here I'm cutting out the actual cylinder mounts. The upper one's going to be made out of 1/4 inch and the lower mounts are going to be made out of 3/16 plate. It's kind of working with what I had salvaged, and I didn't have enough 1/4 inch here kicking around to make them all out of. So beauty is this is just the files I kind of made earlier, and you can just put whatever metal thickness you want on in there, adjust your cut speed, and cut anything thin or thick with the arc droid. If you are interested in the arc droid, there's a link below. If you do order through that, it does help me out a little bit. It gives me a little bit of a kickback to make more of these videos. Unfortunately, there's no promo code for you to save anything on there, but I do have some videos on the arc droid that talks about the setup I have for the air dryer, what kind of plasma I'm using. There's a lot of CNC ready plasmas out there now. But yeah, check it out. I'll put a link below to that video. It covers a lot more about tips on running the arc droid, keeping nice dry air to it, and my downdraft table setup here. Cutting out a whole bunch of gussets. The gussets make a big difference for when you build the stuff. It makes stuff way more sturdy. But, you know, even if you cut it out and it's super quick on the arc droid or any plasma cutter, still got to go through, chip some slag off it, clean up the mill scale on the edges before you weld anything. Yeah, it's crazy what gussets will do to add the strength to it. So I'm just kind of going through here and welding all this little kits of gussets I cut out on the arc droid onto here. Clamping everything, making sure nothing's moving around. Tack it in place first. Make sure you're happy where it's at. So you can always cut off a tack. It's a lot easier than removing a bunch of weld later on, especially in really hard to get to spots. So, and if you're welding around cylinders like I am, I got that one all covered with a leather glove and some tape because the welding splatter will just stick to any type of cylinder chrome plating. This quick disconnect plate showed up from Amazon. Just like people suggested, you have to weld some stuff in here to make it fit tighter. It's kind of a little loose in one direction. I also got these pins, which are going to be set up so I can quick disconnect the hydraulic cylinder if I want. And I got some quick disconnect fittings, which actually fit the skid steer. The skid steer did say ISO 16028 SF3/8. So I've ordered some 3/8 flat fittings, quick disconnects, and they fit great. And I ordered some coupler adapters from pipe thread to JIC for the existing hoses I have. I also put in an order of surplus center for some longer hoses because I think when I rolled the grapple all the way forward, these short hoses I had on stock, free stuff, that were just salvage, I think would get ripped apart, so we don't want that. So this quick disconnect was like 78 bucks or something like that on Amazon, and I knew I was gonna have to do some modifications to it. This way, right and left, almost seems a little too tight. I mean, it fits on there, but there's not much play. The play you see there is between the pins and the main lifting arms. Where this thing has a ton of play is up and down. Wouldn't even lock on the pins, plus this overhangs further than the stock bucket, so I needed to cut out a little section for the quick disconnect. So we're gonna modify this. So the build quality in this disconnect plate was pretty decent. 1/4 inch, decent bends, decent weld, but I'm just a little disappointed I had to spend so much time cutting it to modify it to fit my machine. If you don't have a plasma cutter, I'm gonna mention get one. They're super useful. This one right here is only 50 amp, and I'm trying to cut some 1/2 inch. It's a little bit of a struggle with my 50 amp, but man, the price has come down on those things so much. Well worth your time. If you do much metal fabrication, just treat yourself. I got a video down below on some machines I recommend. So it fits on there pretty good now, but for the 78 bucks, not bad for all that 1/4 inch. I just wish it would have fit my machine better. I had to weld in some like 1/2 inch plates on the bottom, tighten it up, and all time spent cutting the parts and cutting off the top to clearance it. Maybe that's worthwhile for you. I wouldn't mind spending maybe 100 bucks or a little bit more just to get one that fits properly. I didn't feel like the 2 hours is really time well spent. This grapple I don't have that much time into, and to spend that much time on a pre-made part that's supposed to kind of fit. But I did see in the reviews, people said, yeah, I had to tighten it up a little bit, fit a little loose. I think I'll put the link down below to Amazon if you want to check it out. Maybe it'll fit your machine better. Maybe mine has a weird plate. But honestly, there's got to be better fitting ones out there. Time will tell. Maybe I'll find a better one on the next project. So here I'm firing up my welder again to tack weld this quick disconnect plate. Got it all clamped in place where I want it. I'm going to make sure it fits on my machine and clears that rollback tilt cylinder for the bucket cylinder. It's pretty close on this machine. I knew that would be kind of an issue, but it looks like it clears everything, clears the hydraulic lines, no problem. Nothing's getting pinched there. So with that being said, I'm going to put it back on my welding table and disconnect it from the machine and go through and weld it out fully so it's permanent. With the test fit in there and those tack welds, I was pretty happy with it, so I'm going to commit to it and weld it out permanently. Once you do that, you're set, man. It's not coming off very easy. Here it looks like I'm cutting out some tiny gussets, but they're actually pretty large. These are going to actually hold the lower forks from filleting out and bending. The reason I did 4 bigger gussets rather than 2 big ones here was because I kind of had more flexibility with the material I had on stock. It was, I think, 3/16 plate. Right here, I'm kind of clamping on some flat bar. Going to use some other clamps here just to help with alignment. It was just easier to do 4 gussets and weld them in like this than, like I said earlier, with 2 large ones. This should be pretty good. Time will tell, you know, if these things get bent up and beat up, then I'll put some more crossbars in there. But I'm trying to keep this grapple as light as possible because my machine's only like 1,600 pounds. I don't have any counterbalance on it yet. I wouldn't mind adding a few weights on the back. But a lot of the commercially built grapples you can get for these machines seem like they're so robust. They're probably pretty durable, but they weigh a lot. Any type of logs or anything you put in there starts really causing the back end of the machines to get pretty light. So I was trying to avoid making this grapple overkill, mainly for moving light logs and some branches. Here I'm adding on some more gussets, test fit. Gonna maybe hook up the hydraulics here and open and close it, see how it works. Well, it's sure nice to see that thing finally working under hydraulic pressure there. Now that we got the main grapple built, we're going to go through and cut out a few more detailed parts like these hexagon washers here. These are going to get welded on over the heads of the 5/8" bolts for the pins. This is going to keep the bolts from rotating when you open and close the grapple. Later, we're going to go through and drill and tap those on my lathe to put some Zerk fittings in. Putting a little bit of primer on here. I dug through my paint stash and I had some of this primer left over on my shelf. Been trying to go pretty budget on this whole project, like salvage hydraulic lines, salvage paint, just dug around my shop what I had for bolts and trying to work with all the salvage metal. I think this thing all said and done with a few new hydraulic lines I have in that quick disconnect plate, maybe $200 into it at all. Like I said, store-bought ones, the cheapest ones I could find online, like eBay, are about $1,200. So I'll post a few comments I got just on the last video for plowing my driveway, bringing you along to show how these mini skid steers work, if they work at all for plowing driveway. It was paid out of pocket. I paid for this machine 100%, and I got some pretty rude comments. This is just a handful of them. Makes me kind of want to just disconnect the comments from the videos, but unfortunately YouTube says they will not promote your videos as much if you don't have comments. So it does make me kind of wonder sometimes if it's worth even making these videos. So once I had the hydraulics hooked up on here, I took this thing out to the real world situation, clamped a bunch of logs at different angles, stressed the hydraulics, and found that this needed upper support. And it makes sense. I was trying to build as light as possible, but this top support was flexing back. So went through there, put a nice support on that. Up here I got some flex, so I used the hydraulics to straighten everything back out. Put this flat bar in here. Just went through, tested it in real life situations. You're never going to know where it's going to flex and bend. Again, I was trying to make it as light as possible for this machine, and you got to find your limits, and I found them. And went through there and re-gusseted it and made it extra strong. So this is the final gusset I put on the back. I would have liked to build this out a bit further here, but this fitting on this tilt cylinder is so close that will actually kind of cut in around the edge of that. It's about as close as I would like it. If it came out another inch or two, it'd be great. It would really make this extra strong. But all in all, having that support bar I should have done originally. I was just trying to keep the weight as light as possible on this thing. Really should have put that support bar in there and tie something else like this on. So that top hydraulic mount should be pretty solid after this. Hopefully this 3/16 flat bar across the front here will stiffen this 1/8 inch pipe up. I mean, it makes sense that it was going to be the easiest spot to bend there. I should have gusseted that up even more, but yeah, try it out, see how it goes, and build it up from there. You don't always know until you put it through the force test and stress it, and now I know that needed to be secured way sturdier, and so did that. So some of the final bracing I'm going to do on this thing, these big, I don't know, 1/4 inch, maybe the 3/8 bars coming down here to support this, and fit a log in here pretty well. I don't think it's going to compromise it much for capacity. And this tube in the center to keep this from bending up and down. Of course, another one over here. And I think I'm going to go through and put, I don't think I have any more square 1.5" stock. I might put a round tube or something down here between these tines just to tie them all together. We'll see what I have. I'm kind of digging through my scrap pile now to figure out what kind of metal I have left over. Most of this has just been stuff I've had sitting around here for years. Now for the final touches, I got one of these little weld-on hydraulic hose brackets off of Surplus Center for like $6, and it was kind of a nice little way to make sure those hoses don't get pinched. They run all the way down to the pivot point down there by the pins, and they're out of the way. Everything works really well. Speaking of scrap metal earlier, here's some scrap metal I have. I just pretty heavy beams and moving to a different location, trying out the Grapple. All in all, I think the Grapple works pretty good. I haven't had a bunch of time, moved maybe 10-15 logs with it so far. So coming up in the spring here, you'll probably see it a lot more in my videos, running the mill, stuff like that, because I think this is going to be fantastic around the mill for moving logs on and off the mill and moving scrap wood away from the mill. But every time I've operated it, I keep thinking about it, that I feel an excavator with a hydraulic thumb is far superior in my needs when it comes to brushing out an area and removing brush. You have a much further reach, you have more manipulation to the Grapple, or the hydraulic thumb I should say, and I just feel like for picking up things, scraps of wood, logs, I have a lot more control with a mini excavator. If you didn't have an excavator, Grapple would probably be helpful, and maybe I haven't found the right job for it exactly yet. I just got it completed recently. Wanted to put this video out there, but I also want to give you that kind of advice too. I find that a hydraulic thumb on a mini X is more useful for me and my needs, but I think as I use this more around my property, it'll be another nice tool to have. Didn't cost me much other than time. Some people think that is a downturn. I had fun in the shop building it. And this is just my take on it. I know there's going to be a lot of armchair people that like to tell me how I should have done this and that different. It's just working with the metal I had and trying to make it as light as possible. But as you saw, I flexed some stuff and bent some stuff, so I had to go there and re-gusset it. But, you know, it's not like I got a big engineering team helping me here. It's just me, myself, and I working on this project and trying to bring you guys along for the video. So I hope you found something useful out of it. You know, also, if you don't have a bunch of fab tools, maybe just going and paying the $1,200 isn't a bad situation. All right, until next time, take care. Bye.